Let us start. Today is 5th of November 2020. So today we have a lesson in computer science and engineering for the group 211. Okay, let us go to the Moodle. Okay, so in Moodle, in новостной forum, the forum of news, we will have a new topic, the 5th of November 2012, laboratory work 12. Which laboratory work 12? Okay, so let us write the headline of this lesson. So this lesson will be about the online compilation of functions. Okay, so online compilation of your own functions. Your own functions. Okay, let us start. Okay, so let us take the previous lecture program. Let us take a program from previous lecture. Let us return to the text of previous lecture. Okay, so and we considered this program. Let us take it. Control C, Control V. Okay, non-executable path. So what we define first? Let us comment the number of elements in line. The number of lines. Okay, so what we do in this program? Let us comment. So, yeah, matrix handling. Matrix handling. So we work with matrix. So, what is first? Declaration. And new function. Each function. Again, matter. Sorry. Okay, again, matter. Matrix generation. Okay, so the headline of the function or prototype. Headline, I'm sorry. for prototype. Here is the headline. So what we do in headline? So we put the name, gene matter, we put the type of the function, and we put the list of parameters. Okay, so let us continue. Let us continue. Declaration of parameter. Or creation of parameter of the function. Creation of parameter, the pointer PM. The pointer PM. Simply this parameter PM, the pointer. Okay. So local variables. Okay. So the cycle, double cycle of matrix generation. Double cycle of matrix generation. Okay, let us comment. Double cycle of matrix generation. Matrix generation. Okay, so what is I? I enumerates the lines. So J enumerates the elements in line. The elements in line. J elements the elements in line. So I enumerates the rows, the lines of matrix. Matrix, it is a table. Okay, matrix table. Table of numbers. For example, table of elements, any elements, numbers, table of elements. For example, numbers. Okay. So I enumerates the lines. J enumerates the elements in. Okay, so first we consider the inner cycle, so the internal cycle we will create the elements in lines. What does it mean create? It means to give each element the proper value in the range from -9, because a random function %20 gives us the elements in range from 0 to 19. So 10 minus 0 is 10. So 10 minus 19 is -9. So the range of elements of values which we give to each element of the line will be in the range from -9 to 10. So let us see the result of compilation. So for example, the range is from -9 to 10. Yes, so here -9, yes, 10 is absent. 10 is absent because maybe it is is absent because very rare, 10 is very rare. So 0 is rare. So in this compile is absent in this compile result. So random function in this result does not generate 0. Okay. Okay. So let us continue. Yes, continue to the comment. Okay, so this is an initialization of the value of the value. Okay, so what we have? So pm plus I times n plus j. So the memory is linear. So if we put pm, so pm it is the number of the first element in matrix. So for example, this matrix, let us see the result. This matrix, which we put it out as a table with some lines, yes, with a lot of elements in line. So in memory, all this block of elements, all this two-dimensional, so-called two-dimensional array of elements, so appears in memory like a single row, single line, single string of bytes. So each value requires of integer type requires 4 bytes. So 4 times 20, so 80 bytes, 4 bytes in each value. So the line of 20 integers. Yes. Okay, so how to get the first element of matrix? So the number of the cell in which the first byte of the first element is located, so is given by this parameter pm, the pointer. Okay, so what does it mean, this operator? This operator means that we give the value in this number, in this number. So we give the value from this number which is given in the round brackets, and we take the value and changes and change it. We take the value and change it to this value 10 minus 20%, 20. Okay, so pm, the first element, okay, so now I is 0, so we are now in the first line. Okay, so only j works. J changes from 0 to m. So how much elements are in line? So we see that in line we have 4 elements. So from 0, zeros, 0, 1, 2, 3. Okay, 4 elements from 0 to 3, j changes. J is less than 4, n is 4. So 0, 1, 2, 3. Okay, so 0, 1, 2, 3. So 4 times we will have the performing this operation. Okay. Yes, so after the first line, after j becomes 4, so becomes 4, so 0, 1, 2, 3, 4, the fifth in line. 0 to 4 is the fifth, so j must be less than 4, but after the last step j is 4, so this condition is broken, and we return to the external cycle which enumerates lines. So at the first step of external cycle I was 0 and v goes only in one line. Okay, so after this we go to the next line, I is 1. So what we have? Pm plus 1 times n is how much? N is 5. So PM plus 5. PM plus 5. So which number we obtain? So PM, it is the number of cell in which this element is located. So PM plus 1, it is this number of the cell of this element. PM plus 2, the number of the cell of memory of this element. PM plus 3, the number of this element. Okay, so PM plus PM plus 0, PM plus 1, PM plus 2, PM plus 3, PM plus 4. So we goes to this place, PM plus 4, PM plus 4. But here we have PM plus how much? PM plus 5, PM plus 5. Why? PM plus 5. PM plus 5. So this is PM plus 0, PM plus 1, PM plus 2, PM plus 3, PM plus 4, PM plus 5. Very interesting, very interesting. PM plus 5. Okay, plus J. J is now is 0, so PM plus 5. We go to the next row. Okay, PM plus 5. Very interesting. Okay, so J, I enumerate the lines. Okay, so we have 5 lines, and M enumerates the elements in line PM. Okay, so let us try to change this N to M. What we will obtain. Okay, so let us go to the Microsoft Visual C++. Yes, Microsoft Visual C++. Let us open this workspace. Okay, so let us compile, let us build, and let us execute. Okay, so now I will show you the result of execution. Okay, yes, so this is the result of execution. So the result is the different because of random function, because all the values are generated randomly. Okay, so let us close this result. So we checked. Sorry, we have some message. Okay, so and let us return again to the Visual C++. Okay, so what I supposed to change? I supposed to change this. Instead of N, I supposed to put M, and to see what happens. It will happen. Okay, so here we have M, and what else? What else? So here, let it be M2. M or not? Let it be M. Okay. So let us change the program. So what we change? We change the function of matrix generation, and we change the function of matrix out, of matrix printed. So we would not change now the third function of the searching of minimal element of the row. So let us see only in the screen the result of this function of out matrix. If we change here N to M, so let us compile, so let us execute. So please see the result of execution. Okay, so it appears that nothing happens. Okay. Nothing happens. No visible changes. Okay, so let us see how it compile the minimal element. Okay, minimal element of fourth row of matrix A is minus 5 of fourth row. 1, 2, 3, 4. 5 is absent. 5 is absent. We did not change the min row function, so minus 5 is absent in this row because we did not change the function of searching of minimal element. Okay, so let us be sure, let us check the B matrix. So the first row, yes, so minus 9. Minus 9 is present here. So here, second row of matrix C, minus 4, minus 4. In second row, minus 4. Yes, in second row, minus 4 is present. But minus 5 in the fourth row is absent, Okay. Okay, so let us return to the Visual C++ and let us try to change the third function. So the third function, what? So Pm plus row times n, row times n. Maybe row times m, row times m. Why m? Because m is 4. Row times 4 times 4. The number of elements in row. Okay, row, not in the column, in row. Okay, so here plus m, yes, and row times m. Okay, so let us try to see the result here. Okay, so let us see the result. Okay, and let us try to check. Okay, so the fourth row, the minimal element is minus 2. It repeated even 3 times. Okay. So the minimal element of the first row of matrix B. Yes, 5, it is the minimal element. Okay, so about matrix C, second row, matrix C is 0. Is 0. What is the conclusion of all these changes? Okay, so let us continue. Let us continue to the compilation. Okay, or even to our Moodle. Okay, so we go to the Moodle. Yes, we go to the Moodle. Okay, so what we do, what we must to do, how to get the element of matrix. So let us try to draw the memory. Draw the memory. What is this? Okay, this is the whiteboard. Okay, the memory. Let us draw the memory. So what we have? We have the matrix, 20 elements. Okay, in memory. In memory it appears like a string of bytes. So now we have 4 elements. Okay, so now we have 8 elements. Now you'll have 16 elements, I suppose. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 4, 16. 16, and it is necessary to add 4 more elements. So this is our matrix. Our matrix, how it appears in memory. Okay, so what is PM? What is PM? Okay, what is PM? What is PM? Parameter PM. PM, it is the number of the cell in which the first element of matrix is located. So let us return. Okay, so this is number of this cell. The number of this cell. Okay, the number. So this is PM, pointer of the matrix. Equal the number of this cell. So I told you that the numbers are given in C++ language, in many languages, like some hexadecimal number. For example, 2, A, F, 0B, for example, or something else. So it is not easy for you now to translate this hexadecimal number to the decimal. So B is how much? B is 11, okay, A is 10, F is 15. So you must multiply 11 to 16 in power 0 plus 0 times 16 in power 1 plus etc. Yes, what is next? 15 times 16 in power 2, 10 times 16 in power 3, and what is plus 2 times 16 in power, how much? 1, 2, 3, 4. This is zeros position, first, second, third, and fourth. 16 in power 4. To calculate and to obtain the result, the decimal representation of this hexadecimal number. Okay, so it is easy to perform for you now. So let us delete all this. Okay, beautiful records, and let us continue. Okay, so the number PM. So what is the number of this PM plus 1? The number of this. So PM plus 2, PM plus 3, PM plus 4, PM plus 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19, 20. Or something wrong. Or something wrong. Yes, PM plus 2. Yes, PM plus 0, PM plus 1, 2, 3, 4, 5, let us enumerate, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, yes, now we see that 19, 18, yes. So from PM plus 0, so PM plus 0, PM plus 19. Yes, so these are not the values which are located in these cells. These are numbers of the cells of matrix. So matrix appears in the memory like a string. So the memory is linear. So this is a citation from the handbook of C by Herbert Schild. So the memory is linear. Okay, so instead of some table in memory, some matrix, we have just a string. Yes, just a string of integers. So each cell occupies 4 bytes because integer, this is a 4-byte type. So the PM, it is the number of the cell in which the first byte of these 4 bytes is located. Okay. So PM plus 1, it is the number of the cell in which the first byte of this 4 bytes is located. But we consider only the 4-byte elements. Okay. Because PM has the integer type. So let us return to our program, for example, here, and see again that the type of PM is integer. If the type of PM was character char, so we have bytes. We have 20 bytes, but PM is integer, so each square in this picture, okay, means 4 bytes. 4 bytes. So PM, it is the number of. Okay, so let us precisely for first byte. Let us draw precisely. So PM, it is the number of this byte. Okay. So PM plus 1, the number of the first of these 4 bytes, and so on. But it is not now. It is bad to see this. Yes. So better to clear. But this eraser is very, very dangerous. Yes. Dangerous eraser. Okay. Yes. So yes, PM. The number. Okay, so we have how much? 20 numbers from PM plus 0 to PM plus 19. Okay. How to take the elements of the first line? So in line we have 4 elements, 1, 2, 3, 4. So this is the first line. First or first row of the matrix, first line. So which numbers we have to obtain? PM plus 0, this is the number of the cell in which the first element in first line is located. So let us return to our example. Okay. Our example. Okay. So for example, in which this element is located. So the next PM plus 1, so the number of cell in which this element is located. So PM plus 2 is absent, 2, PM plus 2, PM plus 3, PM plus 4, PM plus 5. Okay, so PM plus 0, PM plus 1, PM plus 2, and PM plus 3. This is the first line, but we must not take the PM plus something. This is only the number, but we must take the value which is located in this place and change the value. Yes. Okay. So PM only the pointer. So PM, it is the address. Pointer, it is the variable which holds the address, the number of the cell, the address of this location, of this place. Okay, so let us return to our program. Okay. So PM plus, so at the first line I is 0. So I times n is 0. So PM plus J. PM plus J. J changes from 0 to how much? To 4, because J must be less than 5. And J plus plus means that J after each step grows in 1. So 0, 1, 2, 3, 4. Okay. When J is becomes 5, so this cycle, this this condition is broken, so and we go to the next I grows. Okay. Yes. So J is 0, 1, 2, 3, 4. Yes or not? 0, 1, 2, 3, 4. Okay, so let us return. Maybe I have a mistake in my drawing. 5 elements. 0, 1, 2, 3, 4. Yes. So I have a fatal mistake. So yes. Okay. Now I understand the principle of the arrays. Okay. So it erases one element each time. Okay, so this is the first line. Pm plus 0, pm plus 1, pm plus 2, pm plus 3, and pm plus 4. So 1, 2, 3, 4, 5 elements in the first line. Yes, let us compare one more time. Okay, no, 4 elements. So 4 elements. Yes, I was right. Yes, I was right. Yes, so let us return again. So let us erase. Now the eraser is good. Okay, so when I understand how does it work. Okay, does it work? Okay, 1, 2, 3, 4, 4 elements from 0, 1, 2, 3. Okay, so let us return to our program. Let us return to our program. Yes, yes, from 4 to 4. Yes, to 4. Yes, so from 0 to 4. So 0, 1, 2, 3. Yes, let us check again. Yes, 0, 1, 2, 3. So one more time. Yes, 0, 1, 2, 3. Okay, 0 PM plus 0, PM or PM plus 0, PM plus 1, PM plus 2, PM plus 3. So the next line starts from PM plus 4. PM plus 4. Okay, PM plus 4. So in this record, so J is less than M4. So PM plus 4. From PM plus 0, PM plus 1, because I now is 0, so the first line, so only PM plus J. So works in the first line. PM plus 0, PM plus 1, PM plus 2, PM plus 3, and that's all from 0 to 3. So we takes with the help of asterisk operator. Asterisk means that we take the value which is located in this place. So PM gives us address, for example, 20 millions 21. So the next will be 20 millions 22 PM plus 1 pm plus 2 will be 20 millions 23, and pm plus 3 will be 20 millions 24. Okay, so yes, we take the values and we changes each value to this with this rule. Okay, so now it is good. So I changes in which range? From 0 to how much? To 4. So 0, 1, 2, 3, 4. 5 lines. Yes. So here must be put it n. Here must be put it m. So when we finish the first line, so I changes to 1. So, and this I times n begins to work. So 1 times n is how much? 1 times n is 5. Yes, 1 times n is 5. So pm plus 5. Where is pm plus 5? So let us check pm plus 5. Where is pm plus 5? So pm plus 5 is here. But where is pm plus 4? pm plus 4 is absent. Yes, pm plus 4 is absent. So what it is necessary to do? It is necessary to change 5 to 4. pm plus 4 must be the next. Okay, pm plus 4. Okay, so I times 4, not 5. I times 4, because here must be put it the number of elements in the row, in the line, but not the number of lines. Okay, it will be nonsense if we take the number of line and multiply to the numbers of all lines. Yes, it would not work. So instead of n, here must be placed m. This is a mistake. Yes, now it is correct. Okay, so yes, so we have pm when j is 0, so we have pm plus 4. What does it mean j is 0? J 0 means that this is the first element, zeroth element of the second line. Second line. Yes, pm plus 4, pm plus 5. When j is 0, so we have pm plus 4. How we get pm plus 4? We get pm plus what? Plus 4 times n times 1 time. So pm plus 4, yes. Okay, 0 plus this pm plus 4. Okay, plus 0, 4 remains, so pm plus 4 plus 1 plus j is 1, so pm plus 5, so pm plus 4 plus j2, pm plus 6, so pm plus 4 plus j3. Yes, and the second line is terminated. Second line is terminated. So after this we go to the third line. Okay, so this is the rule. So we must change this rule in our future matrices. So here must be put it m. Yes, so the number of elements in the line. Yes, the number of elements in the line. The number of elements in the line. So the number of line times the number of elements in the line. Okay, yes. So matrix C, yes, I to N, J to M, yes. Is it true? Yes, it is true. Okay, so and here true. So this is the first element, but row times what? Row times what? Row times n. Pm plus row times n. Is it true? Okay, pm plus row. Row it is a number of the row, and n it is no the number of elements in the row. 4. Okay, not 5. M again. Okay. Yes. So it is true. Yes, J counts the elements in line. Yes, because we search the minimal element in the line row. Okay. So and here M again. Yes. And here M again. Yes. So now we have the correct way. Okay, this correct way. So as you saw, was realized in this algorithm. So M, 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 and M. Yes. Yes. So this is program. So zero errors. And one more time the compilation result. Let us check one more time the working of this searching minimal function. So fourth row of A, this. So the one is minimal. Yes. So first row of B. So -9 is minimal. Yes, -9 anytime is minimal. Okay, minimal in second row of C. Second row minimal is -5. Yes, it works. Okay, so we have a very good, yes, a very good rule how to obtain the values of matrix, the values of matrix with the help of asterisk operator. Yes, the operator which gives us possibility to take the value from the given address. Okay, and what is the rule? PM, okay, the first address PM plus 0 plus. What we have? The number of elements in the line, in the row. 1, 2, 3, 4. Okay, so or from 0 to 3. Okay, so which variable counts it? Let us return to the explanation. Which variable counts the elements in the line? The J variable. So plus J is plus G plus G plus G PM plus G. But this PM plus G gives us only first line. So how to obtain second line? So each time we must add how much? 1, 2, 3, 4. So what is 4? The number of elements in the line. So after this we must add 4 again, and 4 again. So we must add 4 sometimes. First time 1, after first line 1 time, we must add 4. After this we must add 4 1 2 times to get this, yes, and 3 times in the next block, and 4 times. Okay, so the variable the constant. It is not variable, the constant, because it does not change in our program in comparison with variables. So which constant? The number of elements in the line. So let us return to the explanation, which constant give us the number of elements m. Okay, so let us return to the m. Yes, m. Yes, m. How much times? So first 0 times, because pm plus j works. So second, in second line 1 time, in this 2 times, 3 times, and 4 times. 0, 1, 2, 3, 4. So how much, what is the number of line? So the number of line, the first line has the number 0, because enumeration begins from 0. Second line has the number 1. Third line has the number 2. Fourth line has the number 3, and fifth line has the number 4. So which variables changes from 0 to 4? From 0 to 4. And I vary because I is less than 5, so 4 is less than 5. So from 0 to 4. So this is okay. So I, so times I and plus g, so multiply. Yes, but it is better to change the order. Raise wants to look. Okay, so I times and plus g. So this is the rule how to take the value which is located in each place of memory. I'm sorry. Okay. Yes, so this is the rule for matrix, how to get the value. So instead of this, it is possible to have this record. For example, in this case, it is necessary to have the name of matrix. For example, let it be the name of matrix of all this memory. Let it be matter. Okay. And this is a two-dimensional array. So one time square brackets, it is not enough. So we have to put here the number of elements in the line. How much? 1, 2, 3, 4 elements. What is 4? Constant 4 is which constant 4 is which is m. Okay, 4 is m. So here we must put m, and here we must put the number of lines n. Okay. For example, how to get this element? This is matter. Okay, so in the first line, so the zeroth line. So in declaration, we must declare the, so integer, int, yes, int matter. Yes, in declaration, we must in creation of this matrix in getting from memory this place, this this line of bytes, okay, of integers. Okay, so we must put here the total number of elements in line 4 and the total number of lines 1, 2, 3, 4, 5. Okay. So, but if we point out the value of the proper place, for example, this value, so it is necessary to indicate two indices, the index of the line and the index of the column or place in the line. Okay, so the index of a line is first line is 0. Okay, this is I index. Yes, and the index of column is J. Is J, which column? 1, 2, 3, 4. The fourth column. So, but enumeration begins from 0. So 0, 1, 2, 3. Okay, so this value which is placed in this cell has the name matter 0, 3. Yes. Okay, for example, what is the index of this? What is the name of this value? Matter. Okay. Which line we have? So this is the second line, this is the third, the number is 2, and this is the fourth, the number is 3. So I is 3. Yes, but how much is J? Okay, let us count 0, 1. Yes, so this is 0, 1. So instead to declare first, because we must declare the matrices to create this volume of memory after the creation of the function. So we did not create anything. So in this case, so let us return to the text of the program. When we create the matrices, so we create the first matrix here. So we create 1, 2, 3 matrices. So here we indicate, yes, where in executable part in the main function. Yes, so we create them only here. So here we takes from memory first 20 integer, so 80 bytes. So second 80 bytes and third 80 bytes. And first 80 bytes, 20 integers was called A. The second 20 integer is called B, and the third 20 integers so is called C. How much integers? 20 plus 20 plus 20, 60 integers, and integer 4 bytes. So 60 times 4, 240 bytes we take from memory. So 3 times like in this beautiful whiteboard, blackboard, whiteboard picture. Okay. So, yes. So we would not create anything before creation the function. So instead we create only PM. We create only PM. Where we create PM? Let us see. Yes, where we create? Here we create PM. So we create only PM, and we in this function can use, because PM it is a local variable. Local, it is can be used only in this function. Local variable of this function. Yes. Yes. So other functions cannot use the PM created in this function. So each time we must create the other PM. For example, how we use the matrices. So this function is used. So we give it the address, so ampersand means address of the created first element of first created matrix A. Okay, so and in this matrix we must again in other function we must again put PM. It is this PM of this matrix is not the same as PM of this matrix. Okay, so it has the same name, but it is not the same variable. It occupies this variable PM pointer, variable pointer occupies some variable with attached to this matrix. Okay, so matrix in this sense is similar to the structure. So structure it is the block of some data. Yes. Yes. So each function occupies some memory. So this PM is connected only with this matrix. So this PM has the same name, but is connected with this matrix. It is other PM. But here in using, we see that to this PM we give the same value as for the another PM from this matrix. So the value we give the same here. Okay, and in this case the value is the same, and in this case we give the same value. Okay, but this PM, this place of memory PM is not the same as this PM and is not the same as this PM2. So the names PM are similar, but the location of this PM, the memory, yes, in memory are different. So these are three different variables located in different places. Okay, and I and J are different too. So these are J local variables of this function. This IJ is local variables of this function. So the names are the same, but the places are different. So these are different variables. So these are local variables of this function in PM2. So these are local variables 1, 2, 3, 4 of this function. Yes, and this 1, 2, 3, 4 are local variables of this function. Local means that it can be used only in this block, inside the block. So prototype and the block. So inside this block. Okay, so these values must be used, can be used only inside this block, and these values PM and J may be used only in this block. So before we created the so-called global variables, which we can use in all the text. So the variables which created, described outside any block are called global. So, but the variables created or declared inside the block are local variables, only variables which can be used or so-called visible in the frames of the given block. Okay. Yes, so now you understand this rule, how to use the addresses and how to get from the address the value from the operator asterisk. Okay, yes, so let us explain. So operator asterisk takes the value from given address, for example, from the cell with number PM, or from the cell with number PM plus 1, or from the cell with number PM plus I times M plus G. So the other operator ampersand, operator ampersand takes the address of given value For example, just return. For example, ampersand A00. So it takes the PM of A. So it takes I'm sorry, not PM. It is the address. It is called PM in this function. It is called PM, but it takes the address of this value of the first element of matrix A. So let us create the matrix A. Let us execute to create the matrix A. So let us consider. Okay. So A00. It is not the value is 8. Okay. So but ampersand A00. Okay. Let us return. But ampersand of 8, so of A00 is the address of the cell in which this 8 is located. The address, the number of the cell. Okay, the address of A00. Okay, so the ampersand, it is the address. Okay, so the address of this cell in which now 8 is located. Okay. Sorry, let us return to the text. So operator takes the address of given value. For example, the address in which the value A00 is located. Okay, so let us return to our drawing. Okay, for example, the address of matter 0, 3. It is bad 0. Sorry. 0 is good, but the square bracket is bad. Okay. The address. So how to obtain? So it is necessary to put PM. So let PM be, in our case, PM be, for example, how much? 3A. 3A. What does it mean 3A? A is 10. So 10 plus 3, it is 13. 13. Okay. So matrix 0, 3. This is PM plus how much? PM plus 3. So the address of this matrix in this case will be 3A plus how much? Plus 3. Yes. Plus 3. 3A plus 3. Or it is not 13. So first 16. So A is 10, but second 16 times 3. Yes, I'm sorry. It corresponds one more time. 16 in power 0. This corresponds to 16 in power 1. So we must take, this is not a 1, I'm sorry. 1. Yes, 16 in power, let it be 1. Okay, 16 in power 1. Okay, so we must take A. 13 is not proper at all in this case. So A is 10, so 1 is 10. So 16 in power 0 is 1, so 1 times 10. Yes, plus. It is not 3. It is 3, but it is better to put here 10 times 1. Or 1 times 10, and in this case it is better first to put the power of 16. 16 in power 1 is 16. So 16 times 3. It is not 13 at all. 16 times 3. So 3 times 1 it is 36 times 3 it is 18. So 30 plus 18 it is 48. 48 plus 10 it is not 13, it is 50. It is 58. Yes, it is 58. So 3A plus 3. How to record in hexadecimal? So 61. How to record in hexadecimal system? So 61, we add 3 to 8. Yes, so it is necessary to add 3 to A. A or 10 plus 3, it is 13. 13 is how much? So A is 10 in hexadecimal system, B is 11, C is 12, D is 13. Yes, so 10 plus 3 is 13. So this is D. So it is necessary to change A to D. 3D. 3D. So 3D it is 61. Yes, D is 13. 13 times I'm sorry, D is 13, 13 remains 13. Okay, so 1 times 13. I'm sorry, boys, because girls are absent now. Okay, in your group, so 1 times 13 and 3 times what? 3 times and 16 times 3 and 16 times 3, yes. And 16 is power 1 times 3, so 48 plus 13, it is 61, yes, 61 is 61. So 3D, it is 61, yes. So the address of this element is 3D if PM is 3A. Okay, so what is the address of this element? Let us count. So the address of matrix, if PM is given, so the address of this element, of this value, this is the value, so values are absent in this picture. Okay. In this picture, only the cells, the numbers of cells are presented. 3, 1, smart. It is not smart, it is ampersand. It is not RT2, it is matrix, it is not smart, okay. Yes, so now country we used to put here the equation mark and to translate it to the next row. Okay, this is an equation mark. Okay, we translate. Okay, let us count. So what it is necessary to add. So we may start from this, yes, or it is better to start. So how much it is necessary to add? 9, yes, so to 3D it is necessary to add 9. Or it is better to start from 3A and add 12. It will be the same. To start from 58 and add how much? 9. Yes, 58 plus 9, it will be 67. Or, no, I'm sorry. 58, it is this. Okay, 58 plus how much? Plus 13, it is not 9, it is 10, because it is not 12. 12 is this, I'm sorry. Okay, so this is bed 12 and this is bed 13. Okay, so it is necessary to add 10, or it is necessary to add 13. So 58 plus 13, it is how much? It is 71. Yes, 71, or 3D. 3D is 61 plus 10, it is 71 again. So let us count 3A plus, because we start at PM, because PM is given. Okay, 3A plus, not a plus, I'm sorry. Eraser. It is not A. No. 3, it is not 3, it is 3A. Again 3A, but plus how much? Plus 13. 3A plus 13. Okay, so this is a complicated operation. So 3A, it is maybe better to add 3D plus 10, but it is complicated too. So how to perform 3A plus 13? So 3A in column plus 13. Okay, so let us perform. Okay, A is how much? A is 10. 10 plus 3 is how much? It is D. It is D. Because the limit now is not 10. Is not 10. The limit is 15. F, D, E, F, 15. So this digit, this place is ended in 15. So A plus 3 is only 13. It is D. So this is D, but not 3D. This is how much D? 4D. 4D. Yes, so this is 4D. Yes, yes, 4D. For example, if we have in decimal bad D, okay. Yes, if we have in decimal 11, 11 plus 10, is how much? This would not change, so 3D 61 plus 10, it would not change, so D remain, but it grows in 1, 2, so it grows in 1, 4, so 3D plus 10, so remains 4D, 4D, 4D. Okay, so this is the address of smart. It is not smart. Address of matrix 3, 1 value. This is the address of matrix 0, 3 value. The value must be put it in this place. So this is the name of the value. This is the address of the value. This is the name of the address. Yes. So this is the address, the number. This is the value located in this address. Okay. So this ampersand give us the value which is located in given address. Yes. This operator ampersand give us the address of given value. Okay. So let us return. Let us return. Yes. Sorry. Yes. Percent A 00. Okay. So, but it is enough to explain. So it is not enough, but I explained you all this rule, how to obtain the addresses and values of non-linear objects, for example, two-dimensional array. So if we consider three-dimensional array, so what does it mean two-dimensional? Two-dimensional is matrix, the table of elements. But we can consider, so let us see again the result of compilation. The result of compilation. Yes, this is a table, the matrix, two-dimensional array. But it is possible to consider not two-dimensional, but three-dimensional array, the cube. So in this case, instead of each line, it is necessary to consider the plane. So the first plane, the second plane, the third plane, the fourth plane, the fifth plane. So each plane will be dependent on the elements here. So here we have elements in line, elements in row, elements in line, the number of lines, and the number of this layers. For example, the first layer, the second layer, the third layer, the fourth layer, how much layers will be in our so-called cube. It may be not a cube, because in cube all the numbers must coincide, but this parallelepiped, like in Russian. Okay. Okay, so volume structure. So it is possible to out the cube. So each plane must be out separately. Okay, so for example, it will be the first plane, yes, the second plane, the third plane, the fourth plane, the fifth plane of matrix A. So after this, fifth planes of matrix B, and after this, it's not matrix, it will be cube A, cube B, and 5 planes of cube C. Yes. Okay. So, but it is possible in the case if we have three-dimensional object to elaborate the same rule how to get the elements, how to get the addresses, the same rule for three-dimensional. Yes, like in this case. Yes, so to three-dimensional. Yes, so it must be continued, and here we must add j times something and plus k, for example. J times n plus k. Okay, so, and even not even non-visible in geometry objects, for example, four-dimensional, not three-dimensional like a cube, but four-dimensional. It is possible to, for example, pm plus I times m, j times n plus k times o plus l, for example. If l will be the next index. Okay, and a lot of dimension. Okay, so we cannot imagine four-dimensional. Yes, cube, for example, four-dimensional, but it can be programmed, can be put it out, can be in some layers, maybe some can be put it yes, in some cross sections. Yes, and can be first can be generated. So can each element of this object can obtain the value, like in this case. Okay, so it is all now for the explanation, and now we will try to compile. Yes, to compile. So let us go to the online compiler, GDB compiler. GDB. C online compiler. C online compiler is GDB. Online GDB. And let us try to compile in GDB. It is interesting how much mistakes we will have. Okay, so maybe we have some mistakes in this code. Okay, so let us try to put it here. Yes. Yes, so we would not create anything with the help of new operator. So, and we would not use structure, did not use structure. So let us try in C language. Let us try to compile in C language. Let us press run. Okay. So some error expected declaration of statement printf. Printf. What is second row? Second row of C. Yeah, it is interesting. So only C. printf. Something happens here. Okay, what is wrong? What is maybe I taken not all the text. Yes, so gauge is I forgot gauges. Okay, so let us take, but it compiled all the program. Only the end of program is wrong. Okay, so let us try again. Okay, let us press run. Yes, very well. This is a result of compilation. So do we see no mistakes? Because we would not use the structure, we did not use the structure, we did not use the new operator, yes, dynamical creation, is created statically, but it is not a topic of this demonstration. Yes, okay, so and this is the result. Okay, this is the result. Very well, this is the result. How to show you the result? Maybe this. How to press what it is necessary to press, show you the result. Okay, so, yes, maybe this way. Okay, so this is our program. Okay, so let us print screen. Let us print screen. Okay, so and let me create the picture of this screen. So it is necessary for me to call the paint editor. Okay, sorry. So now I will try to open the paint editor. So I'm sorry, I will stop the demonstration maybe, or how it goes. So I open the paint editor. Okay, so you cannot see all this, and to save, for example, like unknown with png. So and unknown, to put this unknown in the module. Okay, so this is our online compilation. Okay, so the result of online compilation. The result of online compilation of this program in GDB. So let us put here the linking the address of GDB. Okay, some addresses we have. Okay, so the result of online compilation of this program in GDB. So and let us put here the PNG drawings. Yes, this drawing. Okay, so this is a result, but it is here we see that this is a program. This is our program. So main void. So all like in listing. So yes, to compare, but we cannot see results. So it is necessary to draw the other screenshot. So, for example, this matrix A, matrix B, matrix C. Yes, this program finished with exit code 255. Very well code. So the limiting value of 1 byte, 255. Okay, so let us print screen. Okay, let us go to the editor so you cannot see this. Let us put here and let us save like unknown безымянный var. Okay, so let us close this window with graphical editor. Let us return to our okay, and let us put here unknown one. Yes. What this file? Yes. Okay, so this is this screenshot. You can see that this is exactly this program. Yes, at least the part of this program. Yes, and in this screenshot you see the result of compilation. Okay, so maybe it is all for today because I explained you a lot of information. So one note. So it is better. It is better to take. What is this? I don't know. To take the picture of this beautiful drawing. Okay, so now I press print screen. Okay. Okay, so it is necessary to call. You cannot see to open the graphical editor because I just closed it. So, and let us create another screenshot. Okay, безымянный 2, so unknown 3 with extension PNG. Okay, so let us close and let us return to the module. Yes, and let us put here. Maybe here is the explanation. How to get the value from the memory linear representation of the matrix. Let us put here, for example, this shortcut, this drawing. Okay, let us load it. Oh, I'm sorry. BMP is forbidden. So what it is necessary to do? So you cannot see it, to close, to open this file again. Okay, and to rename it like PNG. Okay, so. Okay, so let us load again. Yes, save. Okay. Yes, so this is our explanation. Okay, this is a result of compilation, and that's all for today. So the home task. The home task is the same like in previous lecture. Okay, so let's copy. Let us repeat this home task. Please try to compile this program in GDB Online compiler by your own. Okay, so the results must be different because of print function. Okay, the results must be different. Okay, please send me the photos to the mail. Okay, so maybe it is enough for today. So, but I don't know. So maybe it is better to save all this beautiful record, to save in HTML format. So to go into the HTML format, okay, and to press Ctrl A and Ctrl C to save all this beautiful information before. So now I opened the notepad and put this information into the notepad and try to save. Yes. So after this, I return to the usual site representation. Okay. And so if you interested in HTML, so HTML, for example, let me open the notepad, for example. Yes, HTML, it is not a programming language. HTML, it is a language of representation of location in the screen. Okay, so for example, each sentence must be put in some container. Container occupies with to this so-called text. So this is opening text, this is the closed text, and each sentence must be headlined in its own way. Okay, for example, how we headline the pictures. Okay, so the picture. So we image, yes. So the height of this image, the width of this image, yes. So the source from which we take this image. So this image was stored in this address in the Moodle. Okay. Yes. So it is not easy to locate all this information by your own hand. But in this model, so it appears automatically. So you type something, and the editor HTML. Do you see now? You see now maybe the record HTML. So types the editor types all this HTML code of this page. HTML, it is not so you cannot see all this information. Okay, so it is not our topic now. So what I have to do now? What I have to do now? Now, yes. So this is HTML code of. This is the container text of each sentence to text. So the opening text, the closing text. So each sentence must be handled in this way. So this is the handling of the picture. So the handling of the picture, the resource in which it stored the source in Moodle. So what is next? The height of the picture, the width of the picture. So all the picture must be handled. So this is the container of the picture. So this is the beginning, and this is the end, and this is the end. So image, to understand that it is an image, so the source, the alt, the role, the what is next? Responsive, height, width, so a lot of parameters. And this is the end. This is the beginning, this is the end of the location of the picture in the screen. Okay. So for example, reference of my email address. So this is the beginning, this is the end. So in addition to P tag, so A tag is necessary. Okay, so this is the language not of programming, but this is the language of location in the screen. Okay, HTML. Okay, so now I will try to send it in forum. Yes, yes. Okay, so this is your computer science and engineering. So, and now this is content of our laboratory work. Okay, so after this, let's stop the demonstration. After this, students of the group 211 KI. So first course, I wish you good health. So please wear masks and please learn the material in the Moodle. Please see the touched video. I will convert. I recorded this lecture. I will convert this video and I will put this video maybe in the Google Disk, and I will put the reference to the Moodle. So see you next time. Next time, according to the timetable, next time will be tomorrow. Tomorrow at 2:30 p.m. 2:30 p.m. or 14:30. So please see the future announcement in WhatsApp. I will this evening. I will try this night. This evening I will try to put it in WhatsApp the reference to our not yesterday, but tomorrow's conference. So now see you next time. Stop the record.